Okay, so I wanted to give you an example. This is a hypothetical example. I just threw some numbers in a table to show how the access factor and management factor do affect the math. So here we have, this is kind of a very, very, very simplified range management form. We have polygons that are numbered, estimates of acres, and of course that's easy to do now with our geospatial tools once we've built those polygons. They've identified a plant community type for each polygon. And of course, from our guides, we have the stocking rates, the AUM per acre for each plant community type. So when you do the math and multiply the acres by the stocking rate, you get carrying capacity. I'm really not that nervous, folks. There's the carrying capacity. Okay. And when the agrologist went out and looked, the access adjustment, there is no reduction for access. So this number 10, we assess on a scale from 1 to 10. So 10 means there's no problems with access. They should be able to get to all of that polygon. There's no natural barriers getting in their way. They should be able to get to all that balsam, poplar, aspen. But when they get out there and take a look at what's being grazed, they realize that really only 50% of that polygon is getting utilized. There's something not happening with management to get the livestock all the way through that polygon, even though there's no access issues. Right? So there's no adjustment for access, but we're only getting to half. So it's a multiplication of 0.5. So 79 times 0.5 gives you 39.5. Okay, and the sedge fen, it's sort of the opposite issue. They can't get to all of that polygon. They assess that it's really only 50% of it is accessible. But there's no adjustment for management because the part that there is accessible, they are getting to and they are grazing it. And so the management there on that polygon and that part of the pasture is just fine. In this CMD9, this is black spruce Labrador tea peat moss, you can see it has a really low stocking rate. There really is no forage for livestock in that black spruce peat moss kind of community. So we have a really low stocking rate. We like to account for it in the landscape. Again, this is range. It's less important as rangeland, but has very important ecological values for other resource use, and it's part of the resource that was allocated. So even we monitor it, we account for it in the landscape, we build it as a polygon. Even though it has a low stocking rate, it doesn't contribute a lot to the carrying capacity. There's no access or management issues, and to be honest, we don't really want to have livestock in those areas. So the 10 there is great to see that they're not actually using those areas. And you do the math across, and it'll be the same. Grazing capacity and carrying capacity are the same for that particular part of the pasture, that polygon. But you can see when you add up the grazing capacity, because we have some management issues and some access issues, the grazing capacity is lower than the carrying capacity. Okay, does the math make sense now that you've seen it sort of strung across the table? It's a lot of math to take in. And the RMF is a lot more detailed than that, but that gives you the general sense of what happens to how we adjust for grazing. Okay, this is another slide I like to use to tell you the exact same story, but this is a forested example. So I said when we go out and build stocking rates, we clip forage at our reference areas, and we actually dry and weigh that forage so we can figure out how much forage is being produced on that particular plant community type on that particular ecosite. So this happens to be an aspen rose tall forb, and it is one of the sites we've clipped for many years, and we know on average over all those years it works out to about 800 pounds per acre of forage. But remember, we're only going to allocate 25% of that in the forest. So available forage production is 800 times 0.25, or a quarter of that, and we end up with 200 pounds per acre. Okay, so we don't plan on allocating everything, just the available forage. We'll base our stocking rate on that. A stocking rate based on available forage, if there's 200 pounds of forage, an AUM, a standard AUM is 1,000 pounds and needs 1,000 pounds of forage per month. That's 1,000 pound AUM is the standard that a stocking rate is built upon. So 200 divided by 1,000 is 0.2. Remember the potential, or we take that stocking rate, that AUM per acre, we multiply it by the acres of that particular polygon to get to the potential AUMs, and then we add up all the potential AUMs for the disposition to get to the carrying capacity. So in this example, the 0.8 is because even though they've been allocated that 20 AUMs in that particular community type, there's some natural barrier, there's an accessibility issue. So they're really only using 80% of that, and 20% they're not able to get to. So there's an adjustment there for natural barriers or access, which gets us to 16 AUMs. And of that 80% that they have access to, they're not doing good enough management to get the livestock everywhere. They're only getting to half of that. So we multiply again by 0.5, and we end up allocating them with a grazing capacity of 8 AUMs. Okay, so the point of walking through the math and doing that look at the pyramid look, I call it, with the forage production as the basis of the stocking rate, and then what we end up allocating is just a portion of that forage that's out there. And that's what makes our ecologically sustainable stocking rate sustainable. And when we're also accounting for the lay of the land and management factors, we're including, you know, making that specific for that land base and ecologically sustainable for that particular land base. Clear as mud? It's a lot of math. The point is, though, what we allocate is a portion of what's actually produced out there for forage. Okay, so we have the range management form. We've figured out that we do polygons to plant community types. Each plant community type has a stocking rate. We look at access and management. We have grazing capacity and carry capacity. And we can do that at polygons, and then we sum up the polygons and do that for a disposition level. There's still one more aspect that we need to include to complete the story, to look at range inventory or to assess the grazing that's available to allocate there, and that's range health. And you can see range health mentioned at both within the polygon level and at the disposition level. So range health is a tool that we use, and Barry and Craig both talked about range health and how we need to use it to monitor. If livestock grazing is our resource use on public land, we have to have a tool to manage or to assess our management and how well we're doing on the landscape. And remember, those ecologically sustainable stocking rates are designed to, we want to be able to graze livestock, but we want to be able to maintain all those other ecological functions. So the range health assessment is a really important tool to be able to assess how we're doing with our livestock grazing management, to make sure that we're on track to maintain all those other ecological functions. Okay, so that they're point data. So the inventory was done at a polygon scale, and range health assessment is point data. So the rangeland agrologist has the spatial tools now to click on a point where he wants to do a range health. They want to do a range health assessment, and they click on a point, and the range health form pops up, and they go through the questions and the 5 indicators that Barry described, and they come up with a range score, a range health score. And so that point data is associated with that polygon, and it's associated with that lease boundary. So that's the beauty of these geospatial tools. We have all of this that we can roll up at that disposition level, but we can also roll up that information on different scales, on a natural subregion scale or a regional scale for management planning and that sort of thing. So really powerful tools. Okay, again, the same sort of issue occurs with range health tools. We have sort of standard minimums that we would like to see a range health, either estimate or detailed range health for a polygon. That would be lovely, depending on how many polygons there are. Again, it's a workload issue that you can only do so much, but what has to be done is the range health has to be done to be able to describe the impact of livestock grazing on that grazing disposition, right? There's a fine balance there between how many to do and how many needs to be done to tell the story and to report on what's happening on the grazing out there. But definitely an essential part of the process and a very important communication tool. And the rangeland, or the guides and the plant community types and the guides that Craig talked about this morning relate directly to range health assessment, and particularly on those first 2 questions. The first 2 questions of the health assessment talk about ecological integrity, or the site that we're looking at looks like or has the same plants that we would expect to find on that site without grazing. So the potential of that site is what we're seeing there with livestock grazing, similar or dissimilar to what we expect to see on that site. So we're looking at plant composition. And that's why our plant community pages that list the dominant plant community, dominant species and their constancy, that's sort of an average or a mean, and then how often they're found in the plots. Gives the agrologist an idea of how often they should see that plant in the plant community, and know whether they're if they're seeing any change in that plant community composition. Okay, so question 1 is all about plant community composition and what if it's similar to what you'd expect to see in a reference plant community. Question 2 in range health is all about structure, and if you are seeing the different layers of vegetation that you would expect to see on that site. And that's really an important indicator for us on forested rangelands, and you saw the slides that Barry showed, with the cows in the understory with all that structure. But it's just as important in the grasslands. Okay, so I've talked a lot about reference plant community. How do you know what the reference plant community would be? How does the rangeland agrologist know when they go out there, especially for a rangeland agrologist who is, when you think about it, they're always looking at grazing dispositions. So more often than not, their eye is tuned to that grazing situation. How do they know what the reference plant community should be. How do they know if the livestock grazing has affected the structure of the plant composition? What would be a really easy cheater way to do it? We love it when we find it out there in the landscape. Pardon me? Yeah, fence line contrast. You know, if you're outside the disposition, it's not grazed. It's a really, and you can be fairly confident that you're on the same sort of similar site. A fence line contrast is a great way to look for that reference of what the site should be like. And that's a really good tool for younger agrologists or agrologists with less experience when they're not so tuned at what that ecological site and those plant communities should look like. A fence line contrast is pretty important. Even within a grazing disposition, you might be able to find other areas that aren't grazed, that there's those access issues and they may not graze, so you might be able to find some of those spots. But quite often we don't have either of those. I'd say most often we have neither of those. So it really takes a lot of training that we do with the rangeland agrologist, and it takes years of experience to use the guides and use those charts that Craig showed you at the end to look at the ecotopic grid. Where am I on this? Are my feet wet? Are my feet dry? Those ends are pretty easy to deal with. When we get in the middle, where all the livestock grazing is, on those aspen stands, on those mesic medium stands, it's kind of difficult to pull an E from an F out, but it takes a little bit of training and tuning your eye. But there are some indicators that you can look for, and the agrologist uses those indicators, and they use the guides. They work their way through the tables, read the plant community descriptions to find the best fit. Right? So the guide is really, really key to being able to even start and do a range health assessment. Those first two questions you can't do without being able to understand the site and the site potential and plant community types. So here's an example, and this is a different slide than Craig showed this morning, but it is the Foothills Fescue Natural Subregion. And you can see on this end of things, where we're grazing this rough fescue prairie oak grass with a sustainable stocking rate. We're addressing management issues, we're controlling livestock distribution, and we're able to graze and sustain this plant community in a healthy range health. But as grazing increases, the plant community changes, so we're seeing differences in that plant community composition that I talked about. And we're seeing changes in structure, and that's really obvious when we get to the end and we have Kentucky bluegrass and pasture sage left, and all they are is little green jobbies, those little grazing-resistant plants that are able to withstand the grazing and the trampling from the livestock. Right? So there is definitely a shift in plant composition and structure across here. And what you'll see is, and you'll see in the chart, that they have different plant community names. So this would each be a different page in the plant community guide. You'd find it all under the same ecological range site. And in that section for that ecological range site, you'll see these three plant community descriptions, one after the other in the guide. Right? They're the same site, but they're different plant communities because of the disturbance that's happening there. Here's a forested example where I'm much more comfortable speaking to. Again, we're at this end. This is aspen, rose, tall forb. At the end, we're grazing here. This is grazed with an ecologically sustainable stocking rate, light to moderately grazed. We're managing timing of grazing. We're managing livestock distribution, all those tools and principles that Barry talked about this morning. And we're able to maintain the ecological function, and we're doing well. We can continue to graze there. But as grazing increases or is not managed, you can imagine all those GPS points on that one area and they didn't get off into the other areas. That creates those overgrazing situations. We have to move the livestock around to improve that. We could also maybe not be grazing this forested pasture at the right time of year and creating that different disturbance with the grazing. But here we've got grazing with, when we do the range health assessment, there's something going on. But at that middle of the road, healthy with problem stage, there are some things that we can likely do with management to turn that around and get some improvement. And then down at the far end, of course, we've been grazing too heavy for too long and really have created an unsustainable, imbalanced situation. And you can see the change in plant community composition from here to here and structure from here to here. Right? So those first two questions in the range health assessment, you get full scores here and no scores probably for those questions at this end. Right? And you can remember Johnson's photo with the fescue grass plants, and what's going on above ground is also happening below ground. And you can see how we're really changing the plant community there. It's not sustainable. Oh, and this is my reminder to say that for each of these different successional stages and grazing disturbance communities, there will be a separate plant community page to describe that. We'll work our way from aspen rose tall forb down to an aspen rose low forb. And the ecologically sustainable stocking rate will be different. Right, because we'll have different management goals. Here we're grazing to graze livestock, but also maintain those ecological functions, which we're doing. We can maintain that. But when we're down at this end, we have to change our livestock grazing management. It'll have a reduced stocking rate so that we can stop the decline, stop the trend from getting even worse. This isn't the end of the trail. I tell folks, the next stage is dust and dandelions and fallen trees. So we need to have a reduced stocking rate there to stop that declining trend and to perhaps get some recovery back and improvement in range health and plant community composition and structure. Okay, so there's a very direct link between the ecological classification, the plant community guides, and the range health assessment. So here's to answer your question, Dale. When the agrologist goes out and finishes their work, they've done the inventory, they've got their map, they've attributed that map with a range management form, they've done range health assessments, they really have a complete assessment of the grazing potential out there and how the grazing should be allocated. They have a really good understanding of management issues, things that they could talk to the client to change or to address in their management. So they have a complete summary, and this summary is used for all different kinds of things. Yes, it's really important for us for that administrative function. Say, yes, we've been out and looked at it. This is how much grazing can be allocated. And that information goes into our administrative folks in Edmonton to do the processing, to make that grazing lease contract and to mail that information out to the client. So there's that administrative need that has to be done, and that can be completed once this work is done. But we have all this information now on file, and we have all these great spatial tools, and we have all this imagery, and we have all this range health data. It's really important information for us because it's a point in time that we've been out there and done this inventory and evaluation. So now we have that baseline information. When we go back, we have that inventory to work within again and to improve upon, to maybe add more detail to the second time, but we have that excellent baseline information. Really important for that continued monitoring. And grazing lease renewal that happens, as Barry showed you the process that happens, this work has to be done ahead of time so that administrative function can be done. But when we have this kind of information, that's what we communicate to the clients, right? That's when the agrologists, I say we, that's the capital W, because it's the rangeland agrologist job really to sit down with the clients and have that coffee table discussion about this is what's happening on your grazing lease, this is what I found. A lot of times they can hash it back and forth, and they can, when we have issues where we see spots of the grazing disposition that aren't being used, the livestock producer has likely some very good information to talk about, how he grazed that or how many animals he put out and what was happening there to complement that, right? So it's a very important communication tool to help us address the management. It's also a really important communication tool for us, for the rangeland agrologist, to work with other resource professionals. You can imagine we have lots of conversation with Fish and Wildlife. We have lots of conversations with land use officers or forest officers when we do grazing timber integration. Right? And Craig mentioned that our guides, we're coming at it, we're developing these guides and we have our information, we're coming at it from a range management point of view. But it's really just ecological information. You can imagine having a discussion with Fish and Wildlife about wildlife habitat or endangered species or species at risk or species of special interest that we're trying to manage for, and we have an inventory that we can talk about plant community types. Plant community types are habitat types for wildlife. So it gives us that common language to speak about. A really powerful tool for communication. So all kinds of uses for that. But our primary goal is to make sure that we can translate that information that we found into the management of the grazing disposition so we can meet our management goals for public land grazing. And when sometimes there's some pretty obvious links between what we found in our range inventory and our range management form assessment to what we can do to change in management. So this is a very good example of a lease up around Peace River. This little creek that's running through here is actually Benjamin Creek, and it's a tributary to the Heart River, and the Heart River is a tributary to the Peace River, and a very small geographic area. So it's all happening. This lease is kind of the end of the agricultural world there. To the east is all watershed, green area, it's the headwaters for this Benjamin Creek. And so it was really important. We were approached by the other resource users to address the livestock grazing on the riparian areas along Benjamin Creek, because it is like the headwaters of the creek. So when we went out, again, the Agrologist went out and took a look, and we put GPS collars out there. This was a project done with a watershed group, and so there was some other partners involved in this project. But the red dots, again, are livestock. You know, there was a few cows that were collared that represent the grazing behavior of the herd. The yellow line is the grazing lease boundary, and this is private land. Okay, so you can see that with current management, that's where the livestock were staying, down around the creek, down around the private land where there was actual water development to and a well there that they had access to. And so when we talked to the livestock producer, showed him the data, showed him the results of our inventory and health assessments, we came up with a management plan to address the grazing in the riparian area. So he was able to build a riparian fence. And what this gives us now is that deferred or rotational grazing, complementary rotational grazing system where, yes, we're grazing, we've created a riparian pasture, we're grazing around the creek, but we're doing that for a specific time of year to avoid those vulnerable periods that Barry talked about, so we can manage the timing. But because we can put them in that fence, we can also manage the duration and frequency of the grazing in there. So they're in there for a very short time, they're using that forage, so we're still getting AUMs out of this, but we're doing it at the right time of year, and then we can push the cattle into the north end of the lease, and you can see the effect on disposition. They weren't using any of this before, and now they're getting up to the north end. If we had 3D, you'd still see these purple dots probably hit the window, because a lot of the grazing is still happening down there at the end, and that's that grazing behavior. Right? We have those old boss cows that are used to going home for water, and they're all bucking up against the fence. So the management plan won't end there. There's more plans for fencing and water development in the north to improve livestock distribution.
And was the fence the only management intervention there?
They had water developed here too, Dale. So when they were on this side, there was they pumped out of one of those natural wetlands into a trough. So they had water there. And then they had salt locations that they used as well.
It's surprising how far north they got the distribution.
Yeah. So they will go if you do the management. If you don't do the management, they don't go. They're lazy creatures of habit. Okay? And I usually throw in a husband joke here, but I won't. Okay. Because I have too many friends here that know my husband. That usually works at the women's grazing school. I don't know. Okay. All right, so there are all kinds of management tools, right? We've talked about fencing and watering. Those are pretty standard tools. But what ends up happening, or what you end up talking about at the coffee table with our clients about, can be a whole assortment of things. And really, there is no, where's my chef? There is no cookbook solution. You know, every lease is different. Every operator is different. Every operator's situation of manpower and economy is different. So we really have to be creative to think of ways to manage livestock grazing. But the resources are really endless. And some things are easier to implement, and you can probably do right away. Other things take a little bit of planning, a little bit of resources. You can pull them in later. It's not a one-time deal. But what it does take is working together. And Barry mentioned this right off at the beginning, that when we have this information, we do these assessments and inventories, but it's really the disposition holder, the grazing lease client, that's responsible for that stewardship of that grazing, of that rangeland. So it is definitely the stewardship model that the rangeland agrologist is really important to facilitating. Right? They're the professional that does the assessment. They're the professional that sits down with the client or the other resource agencies and brings together the management plan to address issues or to make sure we're doing that ecological, sustainable grazing. So there's definitely, I hope I've shown the parts of the process where the rangeland agrologist really uses their professional judgment to do the assessment and to work with clients and to bring it all together.